Well, welcome everybody. This is Notes On with Travis and Ross, and we are talking about the origin of the universe. We've been going over the Kalam cosmological argument, which says that whatever begins to exist has to have a cause. The universe began to exist, and therefore the universe has a cause. And we think that this argument strongly implies a cause that very much resembles the God of the Bible. Alexander Vilenkin, a famous astronomer, said that it is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. Some years earlier, Stephen Hawking said that once the oscillation model of the universe, this idea that the universe expands and contracts and expands again, was phased out, he said, and I quote, "Almost everyone now believes that the universe and time itself had a beginning at the Big Bang." So with that in mind, I'm elated that we have Jeff ZWEERINK to help us navigate some of these waters. Astrophysicist Jeff ZWEERINK is a research scholar at Reasons to Believe. He earned his PhD in astrophysics from Iowa State University. His writing and speaking encourage people to consider the connection between biblical truth and scientific evidence. He's the author of numerous books, and he is a project scientist at UCLA. And among the numerous books that he's an author of, if I can hold it up here, Escaping the Beginning, which is a book written just a few years ago that explores all the attempts that modern astronomers are trying to get around this evidence for an absolute origin of the universe. And so last week we talked about the positive evidence for this. And so this week, Jeff, we have you in the hot seat now. We want to maybe try to challenge you a little bit. So Ross, I think you have a curveball to throw at him.
Well, I just want to, it seemed like from last week, and welcome, Jeff. We're so glad you're here. It seemed like we were conflating two different ideas, which are both covered in the popular notion of the Big Bang. The first is the actual creation and existence of the singularity. And then number two, the singularity expanding. There seems to be a lot of scientific evidence for the expansion. But I think from a theological standpoint, from a Christian standpoint, the creation moment, there's nothing, and then one moment later, if you can talk about it like that, there's something. And that something then is what expands, and we call the Big Bang. And I just want to separate those two ideas, and maybe we can talk about each. We talked about the second one last week. Maybe we can talk about the first one this week. And I'll give you the question: is there anything we can scientifically say with certainty about the creation moment?
Well, I think what I would say is this, and I like the way you characterize that, is that there's this recognition between, the Big Bang has these two meanings, and then one is, the universe is in this hot, dense state, and it expands to become all of the stars, planets, and galaxies that we see. And then the question is, what's responsible for generating that hot, dense state? Is it a singularity? Is that the beginning to time? Or is there some process before that generates that? And that's one of the questions that a lot of physicists and cosmologists have today is, okay, yeah, everybody agrees that if you run the universe backwards in time, eventually you get into this hot, dense state. First question is that genuinely a singularity where there's a boundary to space and time? Or does it smoothly transition into something else that doesn't require a singularity, which need not have a beginning? And so that's the ongoing area of discussion. Everybody agrees it's in this really hot, dense state, but is that really a beginning or not?
So as I said last show, to me, the two options are, once you kind of eliminate some of these models, the two options are either the singularity just sort of hung there for all eternity, and then for whatever reason just expanded, which I think causes as many problems for a purely naturalistic understanding of the universe as just the idea that it popped into being.
Mhm.
We're going to talk about this near the end of the show, because I can always tell that our conversations about the Big Bang kind of head in this direction. But fine tuning and all that aside, I've just always thought that anything that begins to exist has to cause. So even if it's not designed, how do you explain just the coming into existence of it? Even if it was just a grain of sand, or just the simplest thing that you can think of, a quark, just something very, very small, simple, and
Mhm.
designed. Just the idea that it came into existence demands a cause of infinite power, or at least immense power. So can you speak to that? I'm not really formulating an intelligent question, but can you speak to just my layperson's musings about this, how it's just, these seems to be the options. What do
Well,
you, where do you go with that?
right, and I agree, and that's one of the chapters in my book is, it seems to be the moment you have the beginning of anything, you now have to you can keep asking the question, okay, what caused that beginning? What caused that beginning? And the only way to get out of just doing that forever is there's got to be, and the term I use, and it may be a philosophically naive term, but that there's got to be just a brute reality, something that just exists. And I see for that, so let's even put it independent of whether our universe began or not. You kind of have three options there. One is that the material stuff has just always existed. And so, if you go back to that hot, dense state, in this model, you've got something where, okay, yeah, it's a hot, dense state, but it's not a singularity. And something on the other side of that is what produced it. And so, you might imagine that you run our universe in reverse, and it contracts and it contracts, and it gets down to this really condensed, hot, dense state. But on the other side, it would be expanding as we go backwards. And so, running it forward, something contracts and it kind of bounces through. Well, now you've got the brute reality is the eternal matter, if you will, that is responsible for producing everything that's out there. I think that's one idea. There's another idea, is that there's these laws of physics, and you get this sort of notion from Stephen Hawking promoted this. Lawrence Krauss obviously did in his book. And I think this is what Alex Vilenkin was talking about, is there are just these laws of physics that cause things to pop into existence. And so, yes, the physical stuff now has a beginning, but the laws of physics, whatever those are, how we do that, I would say it's changing what we've meant by the laws of physics historically, because the laws of physics has always been to describe what's there. Now they become these self-existent entities that cause things, but that's one option. Or you've got a mind outside of that. And, I love Max Tegmark. He comes up with great ways to characterize things. You've either got a mind, which is God, you've got matter, which is the eternal stuff, or you've got the mathematics, which is the laws of physics. One of those three, I don't see how you get around one of those three being the brute reality that just exists. And so now the fact that we have any beginning to talk about, we're now getting back and ask the question, okay, what's the brute reality that's the cause of it all?
Right. Let's play with the idea that the laws, this is Vilenkin, as you said,
right,
the laws of physics are the cause or the explanation for the origin of the universe. If they are not mere descriptions, but they are prescriptive of how the universe will or can or should exist, the only way I can think of that is a kind of like Platonic form.
Yeah.
This is Plato's ideas all over again, which Plato himself would say that because they're abstract, they're causally effete, if you will. They can't cause anything. So how can the laws of physics, I can understand how they can describe something. I can even understand how they can serve as a kind of exemplar that precedes the universe to show how the universe will be. But how could a physical law that is not physical, it's a law of physics that's not physical, how can an abstract immaterial thing cause something?
That's an interesting question, and I'm gonna you'll tell by my answer. I'm gonna kind of philosophically punt on that because I don't know how to answer that.
Yeah.
But I guess I kind of look at it in a little different, or maybe just take a different tact of answering that question. Is to say, all right, let's just say the mathematics is the correct way to look at it. So you've got these mathematical entities; they're self-existent, if you will. So if they have a beginning or an origin or cause, you just simply kind of kick the question down one level. So they've got to be self-existent. They just exist in and of themselves. Like, all right, okay, that's one feature of the laws of physics if they're going to be the brute reality. And now you also have to make that change. And the question you're alluding to there is that, laws of physics have been descriptive of the way things behave, but now we're making them prescriptive. So not only are they self-existent, but they're causative. They can cause things to happen. That's got to be a fundamental attribute. How you get there, I don't know, but it's got to be an essential attribute. And then the other part that comes into that is if you ask the question, how do you get consciousness out of this? Now, a lot of people will say, oh, evolutionary mechanisms, or you get the matter together and you produce consciousness. But it seems to me that has some problems. I just love the question, how can the universe, which can't think, produce something which can think about the universe? If the universe doesn't have that capacity, why do we have the capacity? And there are philosophers who struggled with that. So,
well, have you read Quentin Smith's conceptualist argument for God's existence?
I have not read that one. No.
It's in William Lane Craig. It's a book that William Lane Craig edited, and it's a philosophy of religion reader.
Okay.
And he has modern. This came out in the noughties, like 05, or around there. But he has what was at that time the latest essays that you could find on philosophy of religion, sort of cutting edge. And it was interesting. He featured an article by Quentin Smith, who is an atheist, or was an atheist. He passed away a few years ago.
Right.
And Quentin Smith was famous for saying that he believed that the universe had an absolute beginning, and it literally did pop into being uncaused out of nothing. He just drank the Kool-Aid on that one.
Okay.
He never was persuaded that God exists, but he did have an intriguing argument, which he adopted the highest value of the argument short of acceptance. He said that if you have concepts or ideas, there must be a mind that contemplates them. And if that argument is even partially persuasive, I find it to be a very intriguing argument.
Right.
But if you have just concepts, then you have to have a mind that conceives of them. So even if you do place the laws of physics where Willington wants to, you have to have a mind behind that contemplating those laws and causing those laws to be, which may in turn, as a kind of domino effect, push the universe into existence or something. But anyway, that's right. It's an intriguing thought that one of the options we have kind of entails an eternal mind.
Right.
So really we're left with mind or matter.
Well, no, I agree. Go ahead, Rob.
Yeah, it seems to me like whatever the structure is, whether it's a quantum foam or some mathematical structure that precedes everything, it sure seems like it has the characteristics of design. There's so many, there's an infinite number of ways that primary thing, whatever it is, could exist, and yet it looks like it's really highly fine-tuned to produce a universe that eventually can produce life. So it sure looks like if that mathematical model is correct, that seems like that implies mind first rather than matter first. That seems like a pretty powerful theological argument.
And I would agree. I mean, that's what I find interesting is that we've moved out of, okay, what does the science say, to, okay, if this is what the science says, what are the philosophical implications of that? But, as both of you are describing, as I've thought about the laws of physics are what are the ultimate reality, look at the list of things the laws of physics must have. The laws of physics must be self-existent. They've got to be causative. If there's a mind behind it to contemplate it, well, now that's starting to look a lot like God, just we're calling it a different name there. And so, I don't know exactly how this is all going to play out, but I find it interesting that these conversations kind of naturally move towards, oh yeah, there's a mind there. Whether it's matter, even if we start matter first, if we start mathematics first or mind first, we all seem to be moving towards there's a mind or something that Christians have called God. The Christian God just has more attributes than what we've identified, but those essential attributes seem to be part of that other reality, or that other brute reality, if you will.
And isn't there a serious problem, Jeff, with the matter first model from a thermodynamic standpoint? If the matter exists first, isn't it going to burn itself out at some point? And what infused it with the energy in the first place? There, you're right back to a mind with power. How do you have pre-existent eternal matter without it running into some serious thermodynamic problems?
So these are questions that various folks have talked about with quantum gravity models, and how do you address that? And I'm not, each of those solutions tends to be fairly technical, but so one of them out there is that you've got this
cyclical. To understand them.
Okay, all right. Well, one is you've got this cyclical universe where, yes, the universe starts in this hot, dense state, it expands, but eventually it grows so large that you end up with this vacuum of space, which starts the cycle over again. And so, because you can show that from a conformal mapping, that end state and the beginning state are the same. And so that's one solution out there. That's Roger Penrose's solution. So you've got these ideas that wrestle with that, and they're working through the mathematics. One of the things that we've got to be careful with, though, is just recognizing that in a lot of these things, so if you take the matter as eternal, well, it's eternal, or it's in a time way infinite, space probably spatially infinite as well. How you deal with finite quantities like, entropy is increasing or the amount of usable energy is decreasing. Well, if there's an infinite amount of energy or an infinite amount of stuff, the amount of usable energy never decreases. Infinites behave different than finites. And so you just got to be careful how you have that discussion. But I know these are the types of questions that people are asking. And the models, these quantum gravity models that they've produced, are purported to address these in some way. Now, whether they're right or not, it's a whole different question. And how we test them scientifically is also an equally difficult whole nother question. But nonetheless, people are aware of that question you're asking and have built models that try and address it, or are designed to address it.
One of the criticisms of William Lane Craig, especially after his debate with Sean Carroll, is that Dr. Carroll seemed very complacent about all of this. He shrugged his shoulders. He kind of waved his hand and said, none of this really proves a beginning. He says, we have many models, and they began rattling off various models of how the universe could be without a beginning. And what I'm hearing you say, and I think I've heard Craig say this, is the problem with that is not that those aren't possible. I mean, sure, they're possible. The problem is they don't seem to be in play right now in terms of just adequate explanations for the data. They're possible models that we have no way of knowing whether they're true or not. There's no probability that they could be true. Am I grasping the problem there?
I would say it a little differently, because where you're talking about the quantum gravity models, they do explain all the data that we have.
Oh, okay.
We just don't have any data to distinguish this quantum gravity model from that quantum gravity model, because the data requires particle accelerators with too much energy or something like that. So it's not a matter of these models are not plausible. It's that we have no way to distinguish whether they're right or wrong, because we don't have any data that will weigh in on that would distinguish them from other models.
And it's my understanding that some of those models point away from a beginning, but some of those models actually point towards a beginning. So
right, yeah.
The idea is, who knows which one of those is correct.
Well, and that's kind of my conclusion as I looked through, going back to Einstein when he introduced general relativity. It's like, oh, here's a way to get away from a beginning with this cosmological. No, that's not correct. Oh, we've got this oscillating model that gets away from a beginning. Well, no, that doesn't work either. Oh, maybe it's a steady state model that gets away from. No, that doesn't work either. Oh, well, maybe the multiverse gets away from. No, the multiverse still has a beginning. Oh, quantum gravity gets away. Well, maybe, I don't know. But the trend line has been every time we've tried to get away from a beginning, the universe seems to keep pushing us back towards a beginning.
Well, let me throw this one at you then. Why is the multiverse not a good way of getting around the beginning? Because if I understand things correctly, we have this universe, and then we have universes sort of spinning off of universes.
Mm-hmm.
So why couldn't that process of a universe expanding, and as it expands, a bubble universe just kind of bubbles off from that, and then that expands, and then eventually another universe? Why can't we just have that going on for all eternity? Why is that a problem?
So the problem, I'm going to give a little bit of historical context, because the question you're asking there is, can this go on forever? Or when you run it in reverse, do you run into singularity where the laws of physics break down?
Right.
Or where it's inaccessible. And so,
but just to clarify,
yeah,
the current universe we have may have that singularity, but that singularity was produced by a prior universe from which it bubbled.
That's one of the possibilities that out there. Yes. Okay. Well, no, because if it produced a singularity, that's a breakdown of the laws of physics, not just we got to figure out how to produce it. So if I can, let me describe this and see if it gets at your question a little bit. So when we had the expanding universe and you run it backwards and it looks like it points to a beginning, people would ask, well, maybe it's not symmetrical, and so it never really collapses, or it never really had a beginning, or maybe. Well, eventually, Hawking and Penrose were able to formalize these theorems, and there's singularity theorems that basically said, if general relativity governs the dynamics of the universe, and if energy behaves in a certain way, and that there are two other more technical conditions on it, but what you can do is that you can show that in a black hole, where you run time forwards, it's going to collapse, and the particle trajectories will cross, and you'll get singularities, and the singularities are where the laws of physics break down, and that's a boundary to space-time. So where you have the laws of physics break down and the boundary to space-time, that's an edge. That in the black hole, it would be an end of the universe there. But what they were able to show is that applied when we ran time backwards in our universe, that the same thing applied, and there was a boundary, and that boundary is what you say, okay, the boundary is the beginning, if you will. The laws of physics break down, that's the beginning. Now, when we're talking about the multiverse, where that comes into play is that inflation, which is what drives one very dominant model of the multiverse, energy no longer behaves in that condition necessary for the singularity to be produced as you run time backwards. And so that seemed to get around the need for a beginning, or it removed the singularity, which was the beginning. Well, what Bourdais, Guth, and Vilenkin were able to show that even so rather than general relativity has to be true, energy has to behave in a certain way, they just said, on average, space-time expands. What they were able to show is that, again, when you run time backwards, you eventually run into a boundary, and that's the marker for the beginning of the universe. And so even these inflationary multiverses still have a beginning to them. And so, there's this odd question of what's the scientific evidence for a beginning? I mean, there is no place where, here the stopwatch says 0. There's no line out there where it says, here's the beginning. But where the laws of physics break down, that's a beginning. Or where you run into this boundary where you can't get beyond, that's a beginning. And so the question is there a similar sort of singularity space-time boundary in these quantum gravity models? And we don't have the quantum gravity model that would allow us to address that yet. But it's really a difficult question to ask, what's a beginning when you're talking about the universe?
I always thought that you could say that a beginning means before whatever it was, there was nothing, literally nothing. And so it went from nothing to something, and that was a beginning. And you're saying that a lot of scientists think of a beginning as just when the laws of physics break down and we really can't talk about it before that. Is that right?
So we're kind of saying the same thing, but the question I would have and I would ask in that description is, what's the evidence that there was something and then there was nothing? Well, to the physicist, there's like, oh, the laws of physics break down. That means now there's something and we can't describe what's before. That's a beginning. Or we can call that a beginning.
Okay.
So I think we're saying the same thing. It's just you're asking the question, what evidence do you have that there was this transition from there was nothing and now there's something?
Well, let's say, Jeff, it's never resolved in science that whether there was ever nothing or there was just something that where the laws break down. Do you think the theological implications are any different for those two positions?
That's a good question. And I guess I'm going to process a little bit out loud to think about that, because I tend to conflate them as being where you say there's nothing and now there's something. The singularity theorems are what delineate, oh, here's nothing now becoming something. I do think that scripture talks about a beginning to our universe. And I think that's what wasn't now is.
Yeah.
But there are these odd passages. I think there's a passage in Hebrews where it says, that the Lord God brought the universe into existence from that which is not seen.
Yeah. Yes.
And so, just from a theological question, I wonder, what does that actually mean? I think all of the stuff we have points to whatever it is that we call this universe has a beginning. Whether there's something beyond that or not that brought it into existence, whether it was God's direct intervention, whether there was some other stuff that produced it that was ultimately or derived from God, that's a cloudier issue to me, and I'm not sure exactly how to think about that. That sounds like one of those fun Christian theology speculations that doesn't get around the point that there's a lot of evidence pointing towards a beginning to our universe.
Yeah, and Genesis says God created the heavens and the earth, which seems to imply all physical existence.
Exactly, yes.
That was a Hebrew way of describing all of the universe, everything that what the Hebrews would have thought to be the entire cosmos.
Yeah,
is stated in the heavens and the earth.
Yeah.
But that still doesn't get around the question of, what does that passage in Hebrews means where he brought it in from stuff that we can't see. I mean, I'm not sure what that means. And there may be there may be something else that was there, that this universe is new. Everything here is new, but it is tied to something that may have existed before. But all that's ultimately still predicated in its origin in God.
Your colleague, Hugh Ross, his paraphrase of that verse in Hebrews 11, the universe came from what we cannot detect, which is an interesting take on the verse, because Hugh seems to be allowing for maybe the possibility of a multiverse, but whatever the multiverse is, that had an absolute beginning according to the Borguth-Vilenkin theorems.
It could just mean the mind of God as well.
Yeah, it could be.
Like I said, great theology to speculate and talk about, and it's beyond my pay grade to know how to answer that any more definitively than what we've done. So.
Well, Jeff, as we said last week, and as Ross and I have tried to do, we try to talk about in the last closing minute or two what this means to us. And I can, just speaking for myself, and I'd like to go just me, Ross, and then let you have the last word, Jeff. When I was in college, I thought about converting to Buddhism. I had a Buddhist professor who walked me through various problems in Christianity. The non-judgmental nature of the Buddhist worldview just seemed very plausible to me. And so for about 2 weeks, I struggled with maybe I should become a Buddhist. I really struggled with this. Well, I came across a book called The Fingerprint of God by Hugh Ross. And he was the first Christian that showed me that you can actually integrate science and theology. He was the first Christian to show me that science is not something that the Christian should be afraid of, but should approach with a sense of wonder and admiration and awe. And when I read that book and realized the strong scientific evidence for beginning of the universe, I couldn't be a Buddhist anymore. Buddha said there's no God, but there has to be a God because there has to be a beginning of the universe, and that means there's a beginner. And so what this kind of evidence means to me is that it was a way God used to stop me from a slide from my Christian position to Buddhism. So I'm not only thankful for the evidence, but I'm thankful for Hugh and Reasons to Believe, for what you guys continue to do with your ministry. Everybody take some time to go to reasons.org and check out what Jeff and Hugh Ross and Fuzz Rana and Ken Samples and others on your staff are doing. We really appreciate you.
And I'll say, Jeff, I ran across Hugh Ross very randomly, a fingerprint of God on a coffee table at a relative's in about 97 or 98. And I'm not a scientist, but I've always had these deep questions, philosophical and scientific, about my faith, and just felt like there was nobody out there that was trying to talk about this stuff. And then all of a sudden, wow, here he is. And then I find out he teaches a Sunday school class in my backyard in Sierra Madre, California. And I got hooked ever since then. And I just feel like for a lot of people, apologetics, the rational, philosophical, theological side to it is not necessary. They hear the gospel message and they believe and they're certain. But for a certain group of people, and me included, I needed to know that there was a rationality behind it, that it wasn't just, good theological ideas, that it really represented the way the universe actually is, that science does point to a creator, and we don't need to be afraid of that. And it really it helped my walk with Christ, because then I'm open to giving myself emotionally to him based on a lot of the rational facts that I had learned. It also made me a lot bolder in sharing my faith with other people. So, Jeff, why don't you tell us how all this has affected you?
Well, I would echo very much your comments. I wasn't drifting to be a Buddhist, but I wrestled with this idea of science seems to be saying something different than what the Bible says. And I wrestled with that for a number of years. And Hugh Ross was pretty instrumental in me beginning to think that, wait, no, these ought to integrate. And ultimately, what I realized through conversations with him and some investigations afterward is that where they look like they're different, that just means I need to study. I don't understand something. That if God is who he says he is, that he's the author of creation and the inspiration for scripture, there will never be a genuine scientific discovery that shows that it's wrong. And so I have become far more confident and much less anxious. In fact, my anxiety about science somehow showing Christianity is wrong has just virtually disappeared. And I can investigate and go in and explore all these things with a confidence and expectation that I'm going to find something really, really cool. And ultimately, at the end of the day, I'm going to have more evidence for who God is. And that has been a great confidence boost and equipped me to be far more comfortable talking to people about it as well.
It's like we're all
Jeff, thank you so much for those comments, and thank you for joining us. It's been a huge blessing, and I want to invite you back anytime. I mean, you've just made our show all the better. And you're better looking than Ross too. So there's that.
I don't know about that last comment, but I really have enjoyed our conversation here today.
Oh, good. Yeah. Well, thank you everybody for listening. And that's another episode of Notes On, and we will be